Okay, my dear students, so yesterday you know that we were doing the methyl benzene. Methyl benzene, we did its preparation and we did its reaction with respect to side chain, and we did the reaction of the side chain. Today we are going to start its reaction with respect to benzene group. Okay, so let's start with the reaction of methyl benzene. Reaction of methyl benzene with respect to benzene group. Okay, guys, I told you earlier that if with the benzene an element is attached which is not having the lone pair of electrons, let's suppose this is the methyl benzene. Okay, so carbon is the element. Okay. So in the methyl benzene, carbon is not having any lone pair. So it is unable to give its, it is not having lone pair, so it does not delocalize its electron to the benzene ring, and it does not need any electron, so it is not going to attract the electron from the ring towards itself. So the reactivity of methyl benzene would remain same. The reactions of methyl benzene, guys, reactions of methyl benzene, they are exactly same as the normal benzene was reacting. Okay, so the reactions are exactly same. So we are going to do the reaction. Let's suppose I'm going to draw the methyl benzene up here. This is the methyl benzene. Okay, so I'm going to react it with the chlorine. So it cannot react with the methyl benzene until it has been changed into abnormal electrophile. So we use AlCl3 because the reactivity of the methyl benzene is unchanged. It does not increase or decrease. So it is exactly same as benzene. So whatever the reactions benzene undergo, this one also undergo the same reactions. Okay. So methyl benzene react with chlorine. So what would happen? Have a look up here. Uh, the chlorine that would be attached either with the position 2 or it would be attached on the position 4 with HCl. Now, the group which is already attached on the benzene, it decides the upcoming group to be attached either on position 2, 4, 6 or on position 3 and 5. So there are the two directing group. We will discuss it at the end of this chapter today. Okay. So chlorine could be attached on position 2 or could be attached on the position 4. Okay. Both possibilities are there and HCl that would be formed. And if you react this methyl benzene with the bromine, so same AlCl3 you need. Okay. And my dear students, this is the methyl benzene. The bromine would be attached with the position 2 or the bromine would be attached on the position 4. And HBr that is being produced. And just like that, if you react the methyl benzene with CH3Cl, so AlCl3 again used as a catalyst. So what would happen, beta? This is the methyl benzene. So the upcoming methyl group is either attached on the position 2 or it is attached on the position 4 with HCl. Okay. And the next thing, that is HNO3, which is the nitric acid. For that, we use concentrated sulfuric acid as a catalyst. Okay. So in that case, my dear, the NO2 group will attach either on the position 2 or it would be attached on the position 4. So CH3 and this position. And H2O that is being formed. Did you get it? Yes. So these are the same reactions. The only difference lies with benzene, the chlorine could be attached on any corner because nothing is attached before. But up here, if methyl group is attached, methyl group is actually 2,4,6 directing group. The upcoming group would attach either on position 2 or 4. The sixth position is only formed. This is position 2, this is position 4, and this is position 6. Okay. So 2, 4, and 6. The sixth position is formed when the 2 is occupied. If you put the methyl group, let's suppose up here, let's suppose, if you put the methyl benzene up here, so the counting would start from that side, 1, 2. So it would be 2 position. But if 2 position is occupied and something attached up here, then it would be position 6. So position 6 only generates when the position 2 is occupied. Otherwise, it would become position 2. Okay? Did you get it or not?
Yes.
Yes, sir. So we got two types of the reactions. Okay? So the reactions with respect to side chain and the reactions with respect to benzene group. The side chain reactions, they were two. The first reaction was free radical substitution with chlorine. Okay? Yeah. And the second reaction, that was the oxidation of alkyl benzene, I told you. Whenever any alkyl benzene is oxidized, it is going to form the benzoic acid. I told you in the yesterday's lecture. So reactions with respect to benzene group, they are exactly same as the alone benzene. The only difference lies, we got the methyl group firstly attached, so it is basically 2,4,6 directing group. So that is the reason, my dear, it would be like that. Anyways, so let's start. 2,4,6 directing groups. Okay. So 2,4,6 directing group, and we got 3,5 directing groups. In some books, 2,4,6 position, they are called as the ortho and para positions. And 3,5 position, that is called as the meta position. But I'm not going to detail, not telling you any complex thing, telling you very, very simplified thing. 2,4,6 directing groups are those groups which got single bond between them. So this is my self-made thing. It's not present in any book. This is just for your convenience. If any group contains single bond, so that is 2,4,6 directing group. If any group got a double bond or triple bond, so that group is, my dear, 3,5 directing group. So what are the 2,4,6 directing group? The first group is alkyl group. Alkyl group, you know that carbon and hydrogen like CH3, C2H5, C3H7. Okay, all alkyl group got single bonds between them. Okay, so alkyl group are 2,4,6 directing group. The second one, my dear, that is the amine group. The amine group is NH2 group. Okay. The third one, that is halogen group. Halogen, chlorine, bromine, iodine. So all these, they also form the single bond. So they are also 2,4,6 directing group. The last one, that is, my dear, hydroxy group or alcohol group, which is called hydroxy OH group. It also got the single bond. So this is also, my dear, 2,4,6 directing group. Okay, what does it mean? It means, let's suppose, have a look up here, guys. Let's suppose OH is attached up here. Just listen, stop writing. OH is attached up here. Where any group is attached first, so that is position 1. It's not necessary that this is position 1. Where the group is attached, this is the first position. Now this OH is having the single bond. So this is 2, 4, 6 directing group. It means if you react this one with something else, the new upcoming group would be attached either on position 2, either on position 4, or either on position 6. Did you get it? हिसाब से होता है जी जी बिल्कुल ये OH ने डिसाइड करना है यानी इसकी एग्जांपल ऐसे है कि लेट्स सपोज दिस इज द रूम मैं यहाँ पे खड़ा हूँ so you people are coming in the class so what I'm going to do I'm going to direct you people you sit here okay because I'm already standing up here did you get it so the group which firstly attached it decides the upcoming group should be attached either on position 2, 4, 6 or 3, 5. So the single bond things, they all are 2, 4, 6 directing groups. Okay, and I told you these all groups they have got single bond between them. On the other hand, 3, 5 directing group, they got double or triple bond. So carboxylic acid, my dear, carboxylic acid got double bond. C double bond O and OH. So this is having the double bond. So this is the 3, 5 directing group. If COOH is attached with the benzene, okay, so it will direct the upcoming group on position 3 or 5. So this is 1, 2, 3. So here the new group would be attached, or on 5 the new coming thing would be attached. The next one, my dear, that is nitro group. Nitro is NO2. NO2 means N double bond O and double bond O. So this is also having the double bond. So this is also the 3, 5 directing group. The next one, that is nitrile group. Nitrile is CN. It is C triple bond N. So it is having the triple bond. So this is also the 3, 5 directing group. You got the aldehyde. So aldehyde, my dear students, C double bond O and H. So this is having the double bond. So this is also the 3, 5 directing group. Did you get it? Okay, guys, this is my question. This is a compound. My question for all of you, tell me that which group was firstly attached, NO2 or CH3? Come on. NO2. So one of my student is saying NO2. NO2 कौन सा directing group है? 3, 5. It's a 3, 5 directing group. And this one, CH3, it's a alkyl group. It's a 2, 4, 6 directing group. ये पहले दोनों को लिखने हैं. Clear? Now what you are going to do, you just find out the place. किसी को भी वन लेने, इसको वन लेने या इसको वन लेने, आपकी मर्जी है. वैसे ही किसको वन लेने बढ़ सा? NO2 को लेंगे. NO2 को वन ले लेते हैं. चलिए जी 1, 2, 3 and 4. तो इन दोनों की अटैचिंग पोजीशन क्या है? NO2 अगर पहले लगा होता, सुने, NO2 अगर पहले लगा होता तो दिस इज 3, 5 डायरेक्टिंग ग्रुप. तो नए आने वाला ग्रुप पोजीशन 3 या 5 पे लगता. तो यहां पे CH3 नहीं लगा हुआ. तो इट मींस इट वाज नॉट फर्स्टली अटैच्ड. ओके, ये अगर पहले लगा होता द न्यू अपकमिंग थिंग वुड अटैच ऑन पोजीशन 2, 4, 6. तो भाई ये देखो ये 1 और 4 पोजीशन पे लगे हुए हैं. तो इसका मतलब है 1 और 4 पोजीशन पे जब लगी हो चीजें तो वो 2, 4, 6 डायरेक्टिंग ग्रुप है. अगर 1 और 3 पे लगी हो तो वो 3, 5 डायरेक्टिंग ग्रुप पहले लगा होगा. तो इट मींस पहले आपका क्या लगा हुआ था? CH3. So this one could react with HNO3 in the presence of concentrated sulfuric acid, then you will get this one. Did you get my point? Yes. Yes, Muskan, we should try for that, beta. Just try it. If it is wrong, doesn't matter. Yes, Muskan. What you think? Which group was attached first? And tell me the reason as well. Have a look up here.
3, 5.
No, it's 2, 4, 6 directing group.
Yes, sir.
2, 4, 6 directing group. And NO2. NO2 I wrote up here. This is 3, 5 directing group. 3, 5 directing group. Now, if you see the positions of these two groups, 1, 2, and 3. So 1, 3. On 1, 3 positions they are attached. It means the first group attached with the benzene, that was NO2. Did you get it? Because the positions up here, they are 1 and 3. Because if this was firstly attached, the upcoming group should attach on position 2, 4, or 6. So NO2 is not attached on 2, 4, or 6. So this is, it means this one is not firstly attached. If this one is firstly attached, the upcoming thing would attach on position 3 and 5. So if this one is 1,
Okay, sir.
2, and 3, so it means this one was firstly attached. Now you get it or not? Okay, so the first group attached, that was NO2, and you reacted with CH3Cl, okay, with AlCl3 as a catalyst. So CH3 would be attached on the position. This is 1, 2, 3. So third position it would be attached. Did you get it? Fatma, Uzair, Yahya,
Yes, sir.
set. Physical students, they got a very big, head. They are saying yes, and I can see them. But online students, I'm asking for you. Is it visible, all of you?
Yes, sir.
That's fine. Thank you so much, my dear. Now we are going to start with the question. Okay. So I'm not going to read the question. I'm just looking at this whole diagram, first of all. We are not doing the question yet. Okay, any one of you could tell me, this is basically having the two carbon and benzene. So this is actually the ethyl benzene. Okay, it is the ethyl benzene. So if you look up here, this one of the hydrogen that is substituted by the chlorine. Okay, anyone could tell me which type of reaction is this and what is the reagent and condition used up here? Come on.
Reagents are AlCl3.
मैं तेरा ना बड़ी सिर पा रही हूँ तुझे मैंने बताया था इधर सुन मेरी बात AlCl3 कब यूज करते हैं बेटा
Free radical substitution.
Yeah, it's a free radical substitution. Side chain है but यार ये CH2 CH3 it's a side chain बेटा so with side chain you got free radical substitution. So this is the free radical substitution and what are the conditions for it? Chlorine with UV light. याद आ गया भट्ट जी?
जी सर.
Thank you very much. Okay, now next thing. बट साहब उसको छोड़ दें कुछ नहीं होता ये प्रैक्टिस कर करके मैंने तुम्हें जितना जलील करना है ना आ जाएंगी चीजें डोंट यू वरी अबाउट इट नेक्स्ट थिंग इफ यू लुक अप हियर दिस क्लोरीन माय डियर दैट इज सब्स्टिट्यूटेड बाय द OH नाउ एनीवन कुड टेल मी व्हिच टाइप ऑफ रिएक्शन इज दिस हाइड्रोजन एल्केन्स में A1 में आप लोगों ने पढ़ा होगा और अंडरगो न्यूक्लियोफिलिक सब्स्टिट्यूशन रिएक्शन जिनको SM रिएक्शन कहते हैं याद आ गया और ये किस चीज के साथ होते हैं विद NaOH and KOH aqueous both of them they produce OH minus sign and I told you yesterday when I make a box that OH minus they are stronger nucleophile than Cl minus, Br minus and I minus so they are going to replace them. So this is my dear the nucleophilic substitution reaction. Okay. And what are the reagents used up here? NaOH aqueous. Is it clear, my dear? Okay. Now,
Yes, sir.
the next thing. This one is secondary alcohol. I'm going to draw it. Carbon, hydrogen, OH, and this is CH3. And this is benzene. So just remember your A1. Whenever any secondary, this is the secondary alcohol. Why? Because the OH group is attached with a carbon which is having just one hydrogen. Two of its sides, this is surrounded by carbon and this one is also surrounded by the carbon. So this is the secondary alcohol. So whenever the secondary alcohol they undergo the process of oxidation, what would happen? The OH from here, okay, I think I should take something else. Yeah, the OH from here and H from here, they would form the water. Okay, and what would be left? You got benzene like that. Okay, C and CH3. And with this C, double bond O is attached, so this one would become ketone. Did you get it? And the conditions for that, acidified potassium dichromate you can use. You can use acidified potassium magnate. You can use any of the thing. So it would be acidified Cr2O7 minus 2. And what are the conditions? Heat under reflux. Okay. Look, this one and this one. अब ये बता देना, don't do the mistake now. Come on. Look, this one and this one. What do you think? Which type of reaction is this? Okay, that's fine, Fatma. Wonderful, beta. It's the pre-radical substitution. Okay, so we have not done yet any question. This was just to make you understand that what this whole cycle, what this whole mechanism is. Now let's start. Any one of you could tell me, suggest a reagent and condition for step one. So this is the chlorine with UV light. Did you get it? Okay, now move towards the next question. Suggest reagent and condition for converting ethyl benzene into compound E. So compound E, he has made it up here. This is the compound E. So can you tell me how could you change the ethyl benzene into this compound E? इतना आसान है। अब लेकिन पहले क्लोरीन बोलना, क्लोरीन plus AlCl3. The reagent is chlorine and the condition that is AlCl3. Okay, did you get it? व्हाट्सएप अपने आप को शाबाश दो।
Yes, sir.
Okay, because chlorine is attached with the benzene group, it means up here the chlorine is used as a reagent. Okay, and the condition up here, my dear, that is AlCl3. Okay, so these two things. Okay, for making this compound A into compound E. Did you get it? Now move towards the next question. Next question. He's saying, draw the structure of the product obtained by heating ethyl benzene with KMnO4. So this is the ethyl benzene. I told you yesterday, those students who were present in my yesterday lecture, I told them just draw this ethyl benzene up here. Everybody just listen. Those students which were not present, they can understand it right now. I'm going to draw this ethyl benzene in a displayed manner like that. So I told you the alkyl benzene undergo the process of oxidation by acidified potassium magnate only, not with dichromate. And the conditions are heat under reflux. I told you whenever you want to do the process of oxidation, just save one carbon and hydrogen attached to it with benzene. Just save this one and change all the other carbons and hydrogen and react them with oxygen to form CO2 plus H2O. So we got one carbon up here, one CO2. We got 1, 2, 3, 4. 4 hydrogen, so 2 water. Okay, so what the thing is left? You got only carbon and hydrogen left up here. Now this oxygen would be joined up here, C double bond O, and with H you got O. So this thing would change into benzoic acid as well. Okay, so it means for oxidation, my dear, whenever you do the oxidation of any alkyl benzene which is having a carbon and having at least one hydrogen attached to it, so that alkyl benzene can undergo oxidation. If you got a alkyl benzene like that, let's suppose carbon, this is CH3, this is CH3. Uzair, you were not present in my previous lecture as well, so you should also see the recording, then you will get to know that how to attempt these questions. So if you look at this carbon, my dear, this carbon is not having the hydrogen attached directly to it. So this alkyl benzene cannot undergo the process of oxidation. So oxidation only happens when the benzene is having a carbon attached having one hydrogen. Did you get it?